With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello dear students, here the question is, a thin uniform circular ring is rolling down an inclined plane of inclination 30 degree without slipping. Its linear acceleration along the inclined plane is. We know that acceleration of a body rolling down the inclined plane is calculated by the formula A equals to g sin theta divided by 1 plus k square upon r square, where theta is angle of inclination, k is radius of gyration. We know that for ring the value of k is calculated by the formula root of I upon m. Now for ring the value of I, that is moment of inertia, is m r square divided by m. So here m will get cancelled, root of r square it will be r. Therefore for ring the value of radius of gyration k is equal to r. Putting this value in equation number 1, we get A equals to g sine of the value of theta is 30 degree, so 30 degree divided by 1 plus k square, that is r square divided by k square upon r square. So it will be equal to g sine 30 degree is equivalent to 1 by 2 g into 1 by 2 divided by, here r square will get cancelled, 1 plus 1 it will be 2. So acceleration will be equal to g divided by 2 into 2, that is 4g by 4. Therefore correct answer for our question is option D. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.